morning, everybody. This is Cysat2021. This is day 3 and the last day of the event. We are broadcasting live from Davos, Switzerland. My name is Matthew Bailey from CISEC, and I'm here this morning with my colleague Patrick. Good morning.
Good morning.
First of all, just to clarify that you tune into the right channel. I do have a Space Watcher T-shirt. This is just a reference and a joke to my colleague and friend Torsten Krinig from Spacewatch. They've been our media partner, so I just wanted to thank them for the good work they've been doing on advocating and helping us to spread the awareness about cybersecurity. Check out the Space Cafe with José Achache. He was one of the co-organizers of the event. That was this week on Thursday. The replay is available on the Spacewatch website. So thanks a lot, Spacewatch, for helping us. Thanks a lot also to all our sponsors. The logos are behind me. To name them, the European Space Agency was the first one to support us. The European GNSS Agency, we had Stefano yesterday. CISEC, obviously, myself, Patrick. We had also Alexandre, our CTO, yesterday as the leading organizer behind the event. Also mentioning our friends from Leaf Space, also a scale-up that took the risk to support the event. Thanks a lot, Giovanni, Taylor, and the team. Space Innovation from Switzerland, IP Swiss also from Switzerland. So thanks a lot to our sponsors to make this event possible. I'm still blown away by the number of participants. I just checked today, 206 participants for the event. We had this crazy idea 6 months ago. Today we are here in the studio in Davos with more than 200 people interested to talk about space and cybersecurity. What a journey, Patrick, unbelievable.
Sorry?
What a journey.
Incredible journey, and I think the feedback of this journey is that in the beginning the space was a real geopolitical market with a monolithic solution, and we see yesterday this new market, new space is a more geo-economic market with solution developed by different provider, developed and integrated by subcontractor with public cloud, with some private cloud, with some embedded system, and with satellite. Okay, and that's really complex, and we need to do some innovation in this field in order to protect the different assets developed with this new infrastructure.
So technical innovation, a bit what we're doing at CISEC with Dockerspace, and also innovation in the culture. We talked a lot about how it is important to spread the word, to talk about security in the space community. It's a new topic. There is no education, formal program on security for space engineers. So the goal of the event was to bring together these two communities, the space and the IT security people. And today, what a great example. We have with us Aris and Xavier, two ethical hackers that participated to the US hacking competition on satellites, HackerSat. Good morning, Xavier. Good morning, Aris. Can you hear us okay?
Good morning.
So this is Aris. Good morning, Aris. And good morning, Xavier.
Hi.
Let me start by asking you, for the people who are not familiar with ethical hacking, capture the flag competitions, can you give us a little bit of an explanation of actually what it is to take hackers and doing these competitions? What does it consist of? What actually do you do? Who is participating? What are the challenges about? Can you give us a brief overview of what ethical hacking and CTF is about, so we understand a bit the context?
Okay, I take this. So we have a bit of a view from the media that the hackers are bad guys who are just destroying electronic stuff. This is not exactly right. Hackers are people who are very interested in technology and want to make extraordinary things with it. Like they want to do things that are not meant to be. And more and more we see hacking competitions in which the goal is not to completely break things, but to be constructive. So a CTF is, so it's a capture the flag. It comes from historical way of doing this kind of hacking challenges in which you have to find a flag on a computer that you have to hack into to find it. And we see more and more diverse capture the flag events for hackers in which hackers have to find holes and security vulnerabilities in all sorts of devices to win the game.
Okay, so this is something that people do as a hobby, right? Is there any professional hacker doing CTF competition, a bit like esport, or is it something a bit still that people do for fun on during their weekends?
It started mostly as an amateur thing, but I think it becomes more and more professional. We see teams who are sponsored by universities or by companies to spend a lot of time on research and apply this research on CTFs. So it's possible that in the next years we will see real esport events on CTF. Actually, this Hackersat event was not exactly esport, but it was broadcasted on internet with video and presenter like in you would see for a sports game.
I have just a small question. Do you need to have a specific mindset or training for participate this kind of event?
I don't think you have only one kind of profile to participate. Of course, you need to have to be curious. I think you have to be curious and have at least a bit of knowledge on the technology involved. But when we started Hackersat, only a few members had prior experience with space equipment, and we all learned it on the fly. Just as the competition started, we
Yeah,
took the
yeah.
technology
We-
and
We'll
saw
we'll
what we could
uh,
do.
we'll talk about Hackersack in a minute. Just to can you guys introduce yourself, just to understand a bit your profiles and where you're coming from and what you do for a living and what you do for fun as a hacker in these competitions.
Xavier, do you start?
Maybe
Oh,
Xavier.
yeah, sure. Yeah, sure. Hi, I'm Xavier. I've been working for Airbus for 10 years, and my work is to find flaws in products that my company uses or produces. So it's quite similar to what we did in the competition, but for products that are made by my employer. For fun, I like to play coding competitions or hacking competitions like the one we did with Aris last year.
So your job is actually very similar to the hacker that we imagine trying to get through things and finding vulnerabilities, and you do that at Airbus for space systems, for satellites.
Actually, this was my first time working on space systems. I work more on IT systems or other flying products, but for space, it was the first experience I had.
Okay, and please give us an overview of the skill sets that are required to participate in this competition. When we think about hackers, you think about the guys behind the screen, so typically very knowledgeable about software, also about security, maybe about also embedded systems. What are the typical sets of expertise that are required to participate to these competitions and to do these kind of things?
Sure. So as Aris said, curiosity is the first asset of a hacker. You have to want to understand how a system works, is supposed to work, how its designers think it works, and how it really works. And you have to find the gap between the two. That is the main asset for a hacker. Of course, you have to have or to learn or be willing to learn about new technologies, because when you try to attack a satellite like the one we had during the competition, you will encounter technologies you have never worked before. So they will bear similarity to what you have found before, but they will be new. So you have to be willing to learn. That is another characteristic. It's quite the same as curiosity. And of course, you have to have some knowledge about embedded development, maybe assembly language, how to debug stuff, how to observe the state of a system. You have to build over time knowledge and know-how on these topics.
What about you, Aris? Are you also doing that during your day, working day, or
Yes.
your professional life has nothing to do with IT and security?
No, I have several hats, but my hacker hat, I spend it on my full-time job. So I'm a security consultant for Sony and work on embedded devices. So not satellites, but other small devices that could fit on your desk. And the process is more or less the same. You get a new device that you don't know. Sometimes it's even using assembly matching architecture that you have never seen before, and you have to understand how it works and how to exploit the fraud.
All right. So I understand these competitions are usually run during weekends. So it's kind of a community where people meet at various CTF. And I understand you also have to form a team, right? Can you tell us a bit? It's a team play, right? You need to find other people to compete. Can you give us a bit of an explanation of the format, the typical format of these CTF competitions?
So usually during this competition, we either have a preformed team. So there are many CTF teams who already play games every weekend. So it's their hobby. They just play CTFs. On our side, we built the team for this CTF because a few people, we were mostly friends and friend of friends, wanted to participate, and we thought it would be a very cool idea to hack satellites.
So you're also representing Solarwine. This is the team that participated to the Hackersat event that we'll talk about in a minute. Can you tell us, is it a team that has been playing on a lot of CTF, or that you, I don't know, what is the background behind Solarwine?
So yes, like I said, it's a team that we built from the ground up for this competition. Some of us, I mean, I would say half of us have already played on other kind of CTFs like DEF CON or other well-known CTFs, but we have not played together before, so it was a first. Yes, we were just interested with the challenge. I don't know, Xavier, if you have anything to add on this.
Yeah, exactly. It's assembled organically, friends inviting friends. I think I didn't know half of the team at the beginning.
How many people were in the team?
About 20 or so.
Okay, 20 people. So you kind of advertised the event, asking for your friends and in the community, saying we have this cool event, hacking satellites. Are you guys interested to join? It's gonna be in a weekend. Do you want to come on in and let's have some fun? Is that how pretty much it worked?
That's exactly that. So at the beginning we had about 20 people. Some of them had I don't know, family constraints and could not participate, and that was fine. We did that for fun. We didn't want to be high ranked. We just wanted to have fun and learn things over the weekend.
So tell us a bit more about this actual competition, the Hackersat. It was the first CTF hacker competition dedicated to satellites in the US, organized by the US Air Force. I guess Solarwine was a French or European team. Did you have to go to the US? What was the format of the competition? I think there were like qualifying rounds and finals. Explain us a bit how this Hackersat competition was organized.
Okay, the original plan was for this competition to happen in the US. So Hackersat was organized with the context of the DEF CON security conference. So it's a very well-known conference for hackers in August every year. And the competition happened in two steps. So the first one was qualification, in which many teams would participate, fight against each other, and only the top 8 or top 10 teams would be qualified for the finals in Vegas. But unfortunately, there was COVID, so it was not possible to go on site in Vegas to participate. So they changed it last minute so we could do it remotely from our houses. So
so you participated to the first qualifying round. and then you made it to the finals. So
Yes,
that was in
exactly.
2 different weekends. And were the challenges similar, or what were actually the challenges? Maybe either in the qualifying round or in the final. Especially explaining why Xavier, you have a small sat sitting beside you.
Okay, I'll take this one. So during the qualifications, there were small challenges that were mostly unrelated, divided in several categories, such as ground segments, communications, payload modules. So small, independent challenges. And then after the qualifications, the organizer shipped us a satellite, a small satellite, training satellite, on which the challenges of the final event happened. For the final, there was a story, a very well designed story. So perhaps I can go in detail, talk about the final event more in detail. So the story was that we have to take back control of the satellite because attackers had disabled it, sabotaged it. So first we had to take back control of the ground systems. So there was a website to hack. Then we had to talk with the satellite to get it in better shape. So to recharge its batteries, so give it orders to orient its solar panels, which we have here, towards the sun, which was simulated in Vegas. There's a picture, I think you can show it, where we can see that they had 8 real small satellites like this in a carousel in Vegas, and it was also broadcast over YouTube. Then we had to improve the performance of the radio, so decrease the bit rate and increase the signal strength. And then there was something that looked more like hacking, like traditional computer hacking. The attackers had installed a backdoor. Oh yes, exactly, that's the picture. Had installed a backdoor on the satellite, so we had to understand the backdoor, which was only in memory, reverse engineer it, and find a flaw in their backdoor and to hack it to be able to execute our own code. And then we had to take a picture with a camera that was added to the satellite to take a picture of the moon. That was the last step of the competition.
Yeah, we see the picture that you guys sent. I am quite surprised, and Patrick, I would like to get your opinion on how realistic is that challenge. Like they really represented first you have to hack the ground systems, then you need to go on the satellite. These guys did really an amazing job at the US Air Force. Like,
Absolutely, yeah. The real to simulate the real ecosystem around the space and try to hack the different vulnerability of this ecosystem. And the security is a chain, and we need to have the protection for each component of this chain, and that's the goal of this kind of competition.
and maybe to come back on the picture we saw. So there were actually actual satellites in the US, and what we see in the picture is that they were sort of floating in the air, right? To simulate microgravity. Did I get that
Exactly.
right? Okay.
Exactly. So the satellites were on an air bearing, so they were able to rotate. And in the satellite, there's one actuator here. So there you can see here, there's a reaction wheel that we can control and spin to spin the satellite and to orient it toward the sun. So exactly.
And so you guys, you had basically no experience in satellites, like you didn't really know. I understood you were not familiar with the electronics, with the hardware and software that are usually on board small sats. So you had to learn, I guess, like the space protocols. You had to learn how our satellite is working, the critical subsystems. How did you do that in one weekend, like to be able to learn how things work and then to hack it? It seems to me a great challenge.
We had more time. I mean, we had the qualification event was there mostly to show us what kind of challenges and what kind of technologies we would have to face in the finals. So we had more or less 2 or 3 months to go through documentation, to continue working on the problems from the challenges, because we had a good glimpse of what the actual satellite would look like. The ISO sent us the satellite so we could analyze it and understand how it works.
Okay. So just to clarify, so you were sent some preliminary information on the challenge, describing how the satellite was built, and maybe
No,
also.
we received the satellite. That's it.
Oh, you just received the satellite. Okay, so really like you get the actual satellite and you get the hands on and try to understand what is it inside, like typical reverse engineering work.
Exactly.
Okay. Amazing. We see also a couple of pictures. What was the screen that we saw with all these colors and tables? That was the main commands that you guys were playing around, or?
Exactly. That was the command, the telemetry reporting panel,
Mhm.
where we see the temperature that's witnessed from the satellite, the acceleration, and the state of the commands. So that was provided by the organizers, a way to communicate with the satellites. What we did is we reverse engineered it and reprogrammed it in Python so that it would be easier to send a large amount of packets of a large amount of data to send backdoors, payloads, whatever. So that was some of the work we did between the time we received the satellite and the actual final event.
It's unbelievable because so you guys received the satellite from the U.S. Air Force to hack it. You spend your evenings, because you don't do that for a living, looking at what components are inside, how you can potentially hack it to prepare for the competition. Is that correct?
You can say that, but we were helped by the fact that the communication standards are all public. It's all the CCSDS standard protocols. So we had specifications. So working from specification and writing program implementation is basically our daily job so for some of us. So that's something we did. Yeah.
Yeah. Maybe explain us also, you had about 20-ish people on the team, and I think it's a bit like a football team. You have people that are specialized in defense, the goalkeeper, the forwards, the middle. Can you explain us a bit what the typical strengths of the team was?
Yeah, so we had some people who were more involved with the protocols. So they worked on the Python interface to communicate and um, to bypass this Cosmos application. Some others were more interested with the low-level details of the satellite. So they started reverse engineering the kernel, the CPU, and how the system was actually working. Some others were reviewing space mechanics and orbital physics, because we had also problems on orbital mechanics. And we just went the way we wanted. So we had many skills in the team, and we just split tacitly.
With nobody in the team, again, just to emphasize that was that had experience in hacking satellites. Like everybody was discovering the topic pretty much.
Exactly, but the satellite does have resemblance to computer systems, because at its core there are CPUs and programs that run on the CPU. So it's something that we're used to. We're used to working with things we don't know about. So that is something we were trained about. The thing that was the hardest for us was orbital mechanics, because that is completely separate from hacking. That is completely different. And one of the challenges for the finals was an orbital mechanics problem. And this one, so we had people who made heroic efforts. They had 4 hours to learn about this and compute trajectories, etc. But other teams were faster, and we couldn't finish this challenge. And that's the only one we could not finish.
And in your team, do you have only Millennium people or person, or is they have different age of the participant of your team?
I would say from 25 years old to 40.
Or more than that, 50. Somewhere a bit older than 40, yeah.
Yes. Okay, yes.
We won't give any names.
One or two
So,
of them.
Yeah.
Okay.
I have a good question from the chat. You mentioned that they made specifically a reference to CCSDS standards and protocols. Can you maybe detail a bit that? Like, were they actually using CCSDS standards, or what was the connection?
So they were using CCSDS standards. We published our implementation using Scapy on our repository, so GitHub/Solarwine. And they were using the lower layers of CCSDS. And of course, the payloads had specific protocols, which we had to reverse engineer, partly from the software that they provided, the Cosmos software, where we have description in, I think it was in Ruby. We have descriptions of some of the commands, so we could understand the payload formats, the APIDs, etc. But there were some of them that we discovered during the finals because they changed some of the firmware during the finals. So we had to reverse engineer and implement parts of the protocols during the finals.
And was it very different from what you've seen on other devices, either during your working day or during other CTF? What was exactly the level of difference in satellites versus other embedded systems or that you've been working? What was so special about satellites? I don't know.
Yeah, I think it's not that different from other embedded systems. So when you get past the major difference with the protocols, the communication protocols and the radio, because other devices, usually you have a USB or Ethernet, which obviously you don't have in space. It's mostly the same kind of thing that we see on other embedded devices. So unless I'm mistaken, there was no mitigation against exploits on this particular operating system. So we are on the security level that we have 1 or 2 decades ago on regular computers. If I'm right, Xavier.
Yeah, I agree. There were typically no protections. So this was a training satellite. So we hope that on real satellites, things are more the state of the art.
Yeah, don't overestimate. That's a question I was about to ask. How well defended was that particular satellite? And you kind of answered the question, like, was there any cryptographic operations involved? Did you have to find some keys to, I don't know, what were the protection mechanisms, if there were any?
Go ahead.
So this satellite was designed to be hackable within 1 weekend. So it was not that hard. By design, it was not that hard to hack into, because if we had to take like 1 month to hack it, then the competition would have been totally less interesting, let's say. But so there were no protections, no defense in depth. So protections against buffer overflows, things that have been standard for the past 20 years, were not there. There were some cryptographic operations that were designed, especially I think in the backdoor there was a hashing that happened, and we had to try and brute force something. There was something like that at some point. Yeah.
I have another question. After this experience, are you now in contact with the space ecosystem? You collaborate maybe right now with some company in the space environment?
Not to my knowledge, we are not in direct contact with space companies, but we were invited to participate to next year event. We don't know what the topic will be if they do it, but we will be invited to participate. And also, I just like to mention that our team is part of some members of the Solarwine team are part of ICOM, which is an organization that is organizing the CTF event, and we want to have space-related vulnerabilities and problems there. So we are probably continuing to spend some time working on space things. And also we are looking for partners. So if you are listening to this and you are interested into being, to help into this kind of event, please let us know.
ICON, yeah, an NGO helping to spread the word about cybersecurity. Thank you, Aris and Xavier. Maybe I think the big takeaway is that we heard, Patrick, that if you're launching satellites without any protection, it takes about a weekend for hackers to get in. This is the kind of the lesson learned. Maybe one last question, because the time is almost up. what would be your recommendation to improve the level of security and to make your job harder to hack satellite? What would be the top 3 recommendations for satellite operators and manufacturers?
Okay, so my take on this regarding software security, I think it would be to get closer to the state of the art, to look at things that are being done by software giants such as Microsoft's software development lifecycle, where they get better at finding bugs and they get better at containing bugs. So I think that's one big focus they should have.
Thank you, Aris. I don't know if you have any.
Yes, maybe try to hire people who are specialized in this kind of problems, because they have a fresh vision. And it's like doing QA. You don't send a satellite into space without testing it, and testing for security should be a priority.
Yeah, and there have been a couple of questions in the chat. So just to clarify again, the satellite and this overall ecosystem that you had to attack during the event was not protected, right? Like there was no security features involved at all. Just to clarify, because some people are worried a bit in the chat.
Yes, this was a training satellite for a hacking competition that was designed to be hackable within 1 weekend. So it was not much hardened.
There was no security on the network side, which we would see on the real satellite.
Okay, thanks a lot for clarifying. We're already late. We could. I would have a lot more questions for you guys, but I think it's gonna be time to wrap up. Thank you so much, Aris and Xavier, to be with us talking about the first hacking competition in the States last year, Solarwine team that recorded the most points. You pretty much won the competition, but got disqualified for some regulatory reasons, right?
Oh no, because we were not good enough at orbital mechanics. That was the reason.
Orbital mechanics. So next year, Solarwine is looking for orbital mechanics engineers to join the team and this time actually win the competition officially. Thank you so much, Aris and Xavier. ICON is the NGO that Aris is representing. Thank you for being with us this morning. That was a great pleasure to learn about this Hackersat competition.
Thanks for having us.
Thank you.
Thank you.
Bye.
While